All right, so you've already watched the video that deals with simplifying rational functions. Let's go through and actually deal with multiplying these. It's similar in steps, but has just one more at the end. So let's take a look here. When dealing with simplifying before, the first thing that I had to do was go ahead and factor everything, and that's exactly what we're going to do here. So let's start off with taking a look at the numerator of the first one, and we know that on that first one there's nothing I can do. It just is left as 5x. But my denominator, I can definitely break that apart. So first terms in each, because it's an x squared, first terms in each are going to be x. Again, we take a look at the sign here, so we see that we have a positive sign, which means that they're both the same signs. And then, of course, we have this one as a positive, so that means that both of them are positive. Then I need factors of 6 that will add to give me 5, and that's going to be 2 and 3. All right, so that's just the first fraction. So now let's deal with the second one. X squared minus 4. Hopefully you recognize this right off the bat as a difference of two squares. So this would be x plus 2 and an x minus 2. Then I take a look at the denominator, and there's only one term, so we just rewrite that. Let me change the color of the pen here so that we can start crossing out parts that we know will simplify out, because they, when multiplied, will just be a factor in the numerator and a factor in the denominator that can simplify. So if we were just to multiply all this out, I'd end up with 5x times x plus 2 times x minus 2, and then in the denominator we'd have the 6x squared, x plus 2, x plus 3. We could write them all as one fraction, but there's no sense in doing that to rewrite it if I can go through and simplify within. Like right off the bat, I see I have an x plus 2 here, and I have an x plus 2 here. So that means those two will simplify out, so there's no reason to keep that. The 5, there's nothing I can do about the 5. The 6, nothing I can do about those two. But notice when looking in opposite, the numerator and the denominator here, I have an x here that I can get rid of. And then I have 1x I can get rid of here. So that just eliminates the square term. If I look within, there's nothing I can do within. There's nothing I can do within this fraction. So really what I have left is I have the 5. I have the x minus 2 in the numerator. I have the 6x in the denominator, and I have the x plus 3 in the denominator. So now rewriting this, it's just going to be 5 times x minus 2 in the numerator. Then in the denominator, 6x times x plus 3. Now there's no reason to go through and multiply all this out unless the problem asks you to. So if it doesn't ask you to, you're done. There's nothing else that you need to do here. All right, so let's take a look at another example. This one is a little bit more intense with the factoring. Matter of fact, it's more intense with the factoring. I actually have a blank slate here so that we can go through and do all the calculations. But let's just try to use over here to write the different parts. So like 2x squared plus 5x minus 12. That's not a quick, easy factoring, but we'll be able to do it, so that's not a problem. So let's go through. I end up with 2x squared plus 5x minus 12. So what we need to do, since this has a leading coefficient other than 1, this is something that we call the division method. So basically I'm going to say 2x, which then that will give me 4x squared, so that's not going to help me any because I need 2x squared, so we have to divide by 2. Take a look at the signs. This is the negative sign, so the negative sign means that we're going to have two different signs. And if I were to go through and multiply this by 2 and multiply this by 2, the difference between the two is what I still want. So in other words, I'm going to turn this to 24 because if you look here, right, the idea is that I'm going to divide by 2. So one of the factors is going to be 2 times larger than what we want. Okay, so now I need to find factors of 24 that differ by 5. Well, factors of 24 that differ by 5. Okay, so that's going to be 8 and 3. And 8 has to be the positive. So 8 goes here. 3 goes here. Now remember how I said, I'm rewriting this and I'm dividing by 2 so that way I can go ahead and one of these factors is going to be 2 times larger. Well, if you look here, this is definitely 2 times larger. So this 2 is going to divide into that factor. And I get x plus 4 times 2x minus 3. Now, if you don't trust me on that one, you can go ahead and multiply it all out, and you'll know that that is exactly what you get. Okay, so I'm actually going to write right next to it, I guess. So I end up with x plus 4, and then we've got 2x minus 3 in the numerator. Looking at this denominator, this is another difference of 2 squares, so I'm going to end up with x plus 4, x minus 4, times, then let's go through and take a look at the numerator here. So I need factors of 16 that will add to give me 8. Well, that's going to be 4 and 4. So this is actually a perfect square. So first terms in each, again, x. Tells me the signs are the same, both negative. So minus, minus. Factors of 16 that add give me 8. Well, that's 4 and 4. Now I got to take a look at the denominator here. This is another one that I'm going to have to do the side work for, like I did there. All right, so just for space sake, I'll put it over here. So I've got 2x squared minus 13x plus 15. Remember, I'm going to go through, do this. First terms in each will be 2x. Then divide by 2. I need to multiply this by whatever that leading coefficient is, so now I'm at 30. I need factors of 30 that add to give me 13, and the signs are both negative. Well, that's going to be 3, and it's going to be 10, so I'm going to put the 3 here, because that's about all I have the room for in that space. And then the 2 is going to divide into this one. So now I'm left with 2x minus 3 times x minus 5. And then this is going to fill in for this part. So 2x minus 3, x minus 5. All right, so now I've got everything factored. So what I need to do, again, I'm going to just change my pen color so that we can go through and eliminate some stuff. Let's look within first. So if I look within this, I've got x plus 4 and an x plus 4, so that makes it nice. So that fraction itself could have been simplified. If I look over here and I try to stay within, there's nothing to simplify within. So now I'll come over here to the numerator. If there's a 2x minus 3 in the numerator and 1 in the denominator, that means those are gone. And then I've got an x minus 4 down here, and I've got an x minus 4 up here. So basically, that entire first fraction is gone because we've gone through and simplified and multiplied, and all that I'm left with is an x minus 4 times x minus 5. And that's it. So this product, it looked really large and kind of ugly, but we ended up factoring everything, and by factoring, we were able to eliminate some common factors in both the numerator and the denominator. And we are simplified down to this when we go through and multiply. So we actually didn't end up needing this page. I was able to fit it, but that's okay. But again, thank you so much for taking your time to watch this particular video on multiplying rational expressions. Hopefully it was helpful. If it was helpful, go through and subscribe to the Charahoe Precalculus YouTube page, or channel rather. And thank you, and have a great day.